Hi guys, today we're going to talk about what's called a rational expression and simplifying rational expressions. But before we really get into all that, we need to talk about just fractions like the one you see on the board, like the ones you see on the board, and what happens when I have 0 in a fraction. So if I have something like 0 divided by 2, 0 divided by 2 is just 0, and you can double check that on your calculator. But you might remember talking about, well, what happens if I have 0 in the denominator? So 2 divided by 0, we can't divide by 0. So we call that undefined. So in a fraction, we can never have a 0 in the denominator. And the denominator, remember, is the bottom of a fraction. So 0 is not allowed to be in the denominator of a fraction. So all right, we know that we can't do 2 divided by 0 or 5 divided by 0, but what happens if I have something like this? What happens when I'm trying to solve these equations for y? If I have, for example, 2 divided by x is equal to y, x could really be any number, right? X is a variable, it could represent any number. But if x was 0, this whole thing would be 2 divided by 0. And we know that that's undefined, so that can't happen. So essentially, we're unable to solve for y when x is 0. So I'm going to write down that x cannot be equal to, or x is not equal to, 0. How about this next one? You might be able to figure out off the top of your head what x can't be equal to. But remember, we want this whole thing to be equal to 0. The whole denominator is not allowed to be equal to 0. So it's not just that x can't be equal to 0, x can't be equal to 5, right? Because 5 minus 5 is 0. If that's hard for you, if you aren't entirely sure how I got that, kind of like a shortcut is to take this denominator, x minus 5, and take the whole thing and say, well, the whole thing can't be equal to 0. So if the whole thing can't be equal to 0, what can x be? Let's solve for x. So x cannot be equal to 5. Because if x was 5, that denominator is 0, and that's no good. So in this last one, again, do the same thing. Take the whole denominator and say, well, the whole denominator can't be equal to 0. So what can x be? Let's solve. X cannot be equal to negative 5. So these values in the denominator that cause the denominator to be equal to 0 are what we call restrictions on the denominator. So a restriction is a value that x, or whatever variable we're looking at, can't be equal to, because otherwise it would make the denominator equal to 0. And as we said, that can't happen. So why are we talking about that? Well, today we're going to talk about what's called a rational expression. A rational expression is a fraction where the numerator and denominator are polynomials. So let's take a minute and break this down. If you think about earlier in the year, we talked about rational numbers. Rational numbers are numbers that can be written as fractions. So 1/3, negative 2/5. So those are rational numbers. So now a rational expression is a fraction, like the 3 that you see over here on the right, but either the numerator or denominator or both are polynomials. So 2x plus 1 is a polynomial. So 2x plus 1 over 5 is a rational expression. So today, we're going to simplify these things. And you know how to simplify fractions. For example, if I gave you the fraction 8 over 16 and told you to simplify it, that means like reduce it. You know that 8 over 16 simplifies or reduces to 1/2. But we're going to talk about, now, what do I do if I give you something like this, x squared plus 3x plus 4 over x squared minus 9, and ask you to reduce that? So here's your steps. And I'm going to show you how we would follow those steps using the fraction 8 over 16. So step 1, factor the numerator. So 8 over 16, I could break that down into the factors 8 times 1. And now I can factor the denominator, step 2. Well, 16 could be 8 times 2, can it? Step 3, set the denominator equal to 0, determine if there are any restrictions. Remember those restrictions we just talked about a couple minutes ago? So in this case, this denominator can't ever be equal to 0 because I don't have any variables in it. But now on to step 4, cancel out common factors in the numerator and denominator. 8 and 8 are my common factors. So my final answer is 1/2. So these are my steps for essentially reducing a fraction, but also simplifying a rational expression. So now let's look and see, how do these work when I have a rational expression like this, b squared minus 10b plus 25 over b minus 5. So step 1, factor the numerator. Well, b squared minus 10b plus 25, that's a quadratic trinomial. That's going to factor into b minus 5 times b minus 5. I'm just going to rewrite the denominator. So step 2, if possible, factor the denominator. In this case, the denominator can't be factored. I can't factor b minus 5 anymore. It doesn't have a GCF. It's not a difference of 2 squares. It's not a quadratic trinomial. So now step 3, we're going to find our restrictions, right? So I'm going to take the denominator, b minus 5, just like we did a couple minutes ago, and say that it can't be equal to 0. So if b minus 5 can't be equal to 0, what can't b be equal to? B cannot be equal to positive 5. That is my restriction. And that's going to be a part of your answer. So then step 4, we're going to cancel out any common factors. So if I go back, I'm just going to rewrite what I have here. So that's what I have when everything's all factored. Common factors are factors that are the same. So I notice that I have a b minus 5 in both the top, the numerator, and the bottom of the denominator. What do I have left? I have b minus 5 on the top and nothing, or in other words, just like a 1 on the bottom. But when I have a 1 on the bottom of the fraction, I don't really need to write it. So my final answer here is b minus 5. All right, let's try a couple more examples. So here's another example. Step 1, factor the numerator. In this case, I have a greatest common factor. My greatest common factor is 5. So I'm going to factor out the 5. Step 2, factor the denominator. So x squared minus 9. No GCF, but that's a difference of 2 squares. That's going to factor into x minus 3 times x plus 3. Step 3, state your restrictions. Well, now in my denominator, I have essentially 2 different parts, or 2 different factors. So I have to take each factor and set it not equal to 0. So I took each factor, set it not equal to 0. So x cannot be equal to 3. Also, x cannot be equal to negative 3. So now I actually have 2 restrictions. Next step, step 4, I'm going to cancel out my common factors. What do both the numerator and denominator have? They both have this x minus 3. So I'm going to cancel the x minus 3. And what's left? I have a 5 in the top and an x plus 3 in the bottom. So my final answer includes the restrictions and also what I get when I cancel out my common factors. So both of those circled parts are a part of my final answer. All right, here's a you try problem. Pause the video, try this problem, and then unpause, and I'll give you answers, okay? So take a minute, check your answer, and notice I have my restrictions circled and what I have remaining after I cancel out my common factors. Both of those things are a part of my final answer. Let's try another one. Here's another example. So step 1, factor the numerator. So in the numerator, 4x minus 20, I notice that there's a greatest common factor. So I'm going to divide each of these things by 4. In the denominator, I don't have a greatest common factor, but this is a quadratic trinomial. So what multiplies to 20 and adds to negative 9? So that's going to be x minus 5 times x minus 4. Next step, so I'm on step 3, is to state your restrictions. But remember, we need our restrictions just on the denominator, and it's each part of the denominator. So x minus 5 can't be equal to 0, but also x minus 4 can't be equal to 0. So now solve each of these little equations, and your restrictions are that x can't be equal to 5, and also x can't be equal to 4. So those are my restrictions. Now step 4, I go up and I look and see, do I have common factors? I notice that I have an x minus 5 and an x minus 5 in both top and bottom. So when I cancel my common factors, all that I have remaining are just 4 over x minus 4. So circle that, and again, remember your answer is what you get when you reduce, and then what you get with your restrictions as well. So same thing as before. Here's another you try problem. Pause the video, try this, factor the top, factor the bottom, state your restrictions, and cancel common factors. When you unpause, you can check your answers. All right, guys, so check your answers here. Notice we factored greatest common factor, quadratic trinomial. We stated our restriction. I circled that because remember, that's a part of your answer. And then after I reduce or cancel my common factors, this is what I have left. All right, we're going to do one more problem together. Ready? So this one's a little different. This one, actually, we could have done a problem similar to this back when we did our unit on exponents. So in this case, the numerator, I only have one term, a monomial, so it can't really be factored. Same with the denominator. It can't be factored. But I can still do steps 3 and 4, and I can still state my restrictions and cancel the common factors. So my restrictions, again, remember they're on the denominator. So the restrictions are where or what can't the denominator be so that the whole thing can't be equal to 0, right? So I take 16r cubed and set it not equal to 0. So this means 16 times r cubed. So I can divide both sides by 16. Get rid of that. So I have r cubed is not equal to 0 divided by 16, which is just 0. And then think about it. R cubed is not equal to 0. So what can I cube to get 0? 0, right? So in other words, that tells me that r cannot be equal to 0. So now that I have my restrictions, let me cancel my common factors. So going back up and looking at the original problem, 16 divided by 16, that cancels out. And r squared divided by r cubed, remember when we divide, we can subtract our exponents. So 3 minus 2 is 1. But the r to the first power stays wherever we had more exponents or the higher exponent to begin with. So this is really r to the first power on the bottom. And essentially nothing is left on the top. Remember what we write if nothing is left on the top of a fraction? We put a 1 up there. Okay? So my final answer when I reduce or simplify is 1 over r. But again, don't forget my restriction is a part of my final answer as well. That's why they're both circled. All right, guys, so here's another practice problem. Again, pause the video, try this problem, and then when you unpause, we can check answers. All right, so the restrictions I have up here, but I thought it might be easier to kind of understand if I walk you through how to simplify this. So my restrictions on the denominator, I got n can't be equal to 0. And then if I look back at the original problem, 15 over 30, 15 goes into both 15 and 30. So it goes into 15 once and 30 twice. So I'm going to start with 1 over 2. And then let's look at the n's. N over n cubed, well, 3 minus 1 is 2, but the n to the second stays on the denominator. So my final answer, and I can write this a little bit nicer if I wanted to, is 1 over 2n squared. That's it. Thank you guys so much for watching, and if you have any questions, please let me know.